Okay, grade 7, this is your probability, oh, sorry, grade 8. This is your probability review for grade 8. And the first 5 questions in your chapter review for chapter 11 says, what are these words? I already gave you most of them, but for those who I didn't, this is an independent event. An independent event. And what an independent event means is something like if I was to roll a 6-sided dice, and then roll another 6-sided dice, the second 6-sided dice does not influence or change what happened with the first dice. An example of a dependent event or a non-independent event would be if I was to take a card out of a deck and then I asked you to take a second card out of the deck. Well, that first, if I said take a card out of the deck, there would be 52 cards in the first deck, and the second time, because there was one less card, there would be 51. So that would change the probability of the second event. So an independent event just basically means there is no influence on the second event or another event. The second word is a sample space. Sample space. And a sample space is a way to organize all of your probability. And usually if we have a tree diagram like heads and tails on the first coin, heads and tails on the second coin, all of your possible combinations would be heads, 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 tails would be a combination, tails, heads, and tails, tails. This is called your sample space. Right here. It's just your organization of all your possible outcomes. The third one is a simulation. And it's a real situation modeling using experiments. So we did 2 simulations in class. One of them was by drawing red, blue, and black poker chips from a bag, and the probability, the experimental versus theoretical probability of those events. And the other simulation we did was when we took 4 coins and we flipped them simultaneously, what the probability of flipping heads on all 4 coins simultaneously was. That's called a simulation. Your third one, a chance of an event occurring, is called probability. And the formula for that, I spelled that wrong, but whatever. Formula for that is favorable outcomes divided by the possible outcomes. That calculates your probability. And finally, a successful result in a probability experiment with 2 words is what we call that favorable outcome. Favorable outcome. Your second question, or your question 6 says, 2 6-sided dice are rolled. Organize the sample space. So when I do a sample space, I can either do all of the different probabilities, or I can actually organize it using a table. So if I make a table, this is what my table would look like, and I can see what is the probability that the sum of the 2 numbers is 10. So sum means add them together. So the first number that we can add together is 4 and 6. If I add those 2 numbers, I have a sum of 10. 5 and 5 is a sum of 10. And 6 and 4 is a sum of 10. Now, that's the only 3 numbers. The only 3 numbers out of the 36 possible combinations that result in a sum of 10. So therefore, as a percentage, if I was to change that down, it would be 3 divided by 36, which means it's 8 1/3% probability. Okay. Now, for the second question, what is the probability that the 2 numbers are identical? For that one, we have a 6 and a 6, we have a 5 and a 5, a 4 and a 4, a 3 and a 3, a 2 and a 2, and a 1 and a 1. So we have 6 chances out of 36, which is in lowest terms 1 chance out of 6. But if I do 6 chances out of 36, the probability is 16 2/3, or 16.6 repeating percent probability. For the second one, it's probably the 2 numbers are identical. And for the third one, what's the probability that the product of the 2 numbers is a multiple of 10? For that one, multiplying 2 numbers together to get 10, or a multiple of 10, well, 2 times 5 is 10, and 4 times 5 is 20, and 6 times 5 is 30, and 6 times 5 is 30, and 6 times, no, just 6 times 5. I think that's, is that it? 4 times 5 is 20, and I think that's it. Is that all of them? Oh, no, right there. 5 times 2 is 10. So those are all of the different numbers on 2 dice that when you multiply them together gives you a multiple of 10. So therefore we have 4, 5, 6 out of 36, which is the same as the last one, which is 16 2/3% probability. In the next question, it says a coin is flipped 3 times. Display the sample space in a tree diagram. So when I look at my tree diagram, this first outcome can be heads or tails. That's the first coin flip. So if it's heads, I could have a heads heads or a heads tails on the second flip, a tails heads or a tails tails. And then if it was heads and then heads, it could be heads again or it could be tails again. It could be heads, tails, heads, or heads, tails, tails. Heads or tails, heads, heads, tails, heads, tails, 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 heads, and finally tails, tails, tails. So when I look at this, there are 8 possible outcomes. And if I organize them, this is what my sample space would look like right here. Right? These are all of the 8 possible combinations. It says, what's the probability of that all 3 flips will result in heads? That would be 1 chance out of 8 for the probability of heads, heads, heads. And for the third part, what's the probability that the flipping of 2 heads and 1 tail in any order? There's 2 heads and 1 tail. There's 2 heads and 1 tail. And there's 2 heads and 1 tail. So that's 3 chances out of 8, which is 37.5% probability. Question 8 says one card is chosen at random from that small deck and 1 standard 6-sided dice is rolled. Show the sample space in a tree diagram or table. Well, obviously, if you're given a choice, if it's two events, you should always use a table. And here's what it looks like. So when I've made my table, I guess the 9 kind of erased a little bit there. When I make my table, I can see that there are 42 possible combinations of card/dice. And so there are 42 possible combinations. And the probability that the number on the card matches the number on the dice would be a 3-3 right there, a 4-4, a 5-5, and a 6-6. So there are 4 chances out of 42. 4 chances out of 42 results in a percentage of approximately 9.5% probability. For C, it says what's the probability the number on the card is larger? So here's our cards up here. So 3 is larger. I'll do it with a red axis. Red. Actually, hold on 1 second. Red circles. So this 3 is larger than this 1. So therefore, this is going to be bigger. This is going to be bigger. But right here, that's actually the same size as 3. So we're not going to circle that. 4 is bigger than 1, 2, and 3. 5 is bigger than the 1, 2, 3, and 4, and so on. So when we look at our sample space, we can see that there are 7 on this row and 7 on that row and 6 here and 5 here and 4 here and 3 here. That makes 10. That makes 20. That makes 27. That makes 32 out of the 42 possible outcomes are the card being greater than the number on the dice. And when I translate that into a percentage, first as a decimal, then think of that as being approximately 76.2%, roughly. And finally, what's the probability that both numbers are even? Here I'll use the green. So even numbers would be 4 and 2 are both even. I guess I'll just shade them like this. 4 and 2, 4 and 4, 4 and 6, 6 and 2, 6 and 4, 6 and 6, 8 and 2, 8 and 4, and finally 8 and 6, which means there are 9 chances out of 42. 9 chances out of 42. 9 chances divided by 42 is 21.4% probability. Question 9 says a coin is flipped and a spin or a spun. List all the possible outcomes. So I'm going to try and do it without a table or a tree diagram. But I know heads 1 was 1, heads 2 is 1, heads 3 is 1, tails 1 is 1, and tails 2 is another one, and finally tails 3. There are 6 possible outcomes. And how can you find out your answer in part B with using multiplication? You can take your first event, which is the coin flip. There are 2 possible outcomes. And event 2, which is the spinner, there are 3 possible outcomes. And you get that sample space of 6 possible outcomes. I can simply multiply them out, and I would get the exact same answer. Question 10 says Janessa wins a contest on the radio. Her prize is the choice of 1 item from each category. So if you have 6 t-shirts, then there are 6 possible shirts that would be used for the combination. For CDs, there are 4, and for the tickets to the concert, there are 2. So the product of those is going to tell you that there are 48 possible combinations for a t-shirt, CD, and ticket. For question 11, question 11 says a travel company is selling a getaway ski package to Whistler that includes a choice of 3 hotels, ski passes to 2 different mountains, and dinner at one of several, it doesn't say how many, but several restaurants. The newsprint advertisement is smudged where the restaurants is listed. So we know that the hotels is 3 different choices. The ski passes is 2 different hills. And this one we can't see, but we know that there are 42 different combinations. So this is really what the question is asking you. So 3 times 2 is 6, and 6 times what is 42? The answer is 7. So how many different restaurants are listed in the ad? There would be 7 different restaurants. Question 12 says a bag contains 3 red marbles and 2 black marbles. A box contains 4 green marbles and 1 yellow marble. 1 marble each is selected randomly from the bag and the box. What is the probability of a red? Well, that would be 3 chances out of 5. And the probability of a green marble would be 4 chances out of 5. But the second question says, what's the probability of both a red marble being drawn and a green marble being drawn? And for this, we need to use the product of our independent events. We would then realize that it's 12 chances out of 25 to do that, which is less than 50%. And we know it's 48, but 12 divided by 25 is 0.48, which is 48%. Question 13 says the probability of snow today in Abbotsford, Lethbridge, and Estevan are these. So this means the probability of Abbotsford, which is decimal 1, and decimal 1 is 1/10, and as a percentage, it really means there's a 10% chance of rain in or snow in Abbotsford. There is a 40% chance of rain in Lethbridge, and there is a 50% chance of rain in Estevan. So if I'm looking for the probability of Abbotsford and Lethbridge, I really want to take the probability of Abbotsford and I want to multiply it by the probability of Estevan. And that's going to give me 5 out of 100, which means there is a 5% probability that it will snow in both Abbotsford and Estevan on that day. For the second one, it says, what's the probability of Abbotsford, Lethbridge, and Estevan? So I'm going to take that there. I'm going to take this here, and I'm going to take this here, and I'm going to multiply it all out to get 20 out of 1,000, which is 0.2 out of 100, which means there's a 0.2%, or if I wanted to, I can change it to a fraction. There's a 5% chance. Not 20%, but a 5%. It's 1/5 of 1%. And question 14 says a standard 6-sided dice is rolled 3 times. Use multiplication to determine the probability that 1 or 2 appears on the first roll, a 3 appears in the second roll, and an odd number appears on the first. So all of these have 6 possible numbers on all 3. So the first dice is either a 1 or a 2, which means there's 2 chances out of 6 for that 1 or 2 to appear. For that 3 to appear, there's only 1 chance out of 6 that that 3 appears. And an odd number to appear, there are half of the dice numbers are odd. So when I multiply that out, I get 6. So when I multiply 6 by 6 by 6, I get, I think, 216. Just double check that. So I go 6 cubed, which is 6. I can use this button right here, cubed, which is 216. 6 divided by 216 is approximately a 2.8% chance that that will occur on those days. And question 15, your last question, says a spinner is divided into 4 equal regions as shown. It says, what is the theoretical probability that the spinner will land on blue on a single spin? Since this blue makes up a quarter of the spinner, your probability is 1 chance out of 4, or a 25% probability that you will get blue. But with the second part, it says from the tally chart above, this was an experiment that they did with 25 spins. And it says, what was the experimental probability of landing on blue on that one? And here, this blue was 3 chances out of the 25 spins, which ended up being just, or 20 spins, sorry, 20 spins. So the 20 spins, which was 15% probability for blue. So it says, give a possible explanation for why the answers in part B this one, and this one weren't the same. And the reason is actually your answer to D is because your sample size was very low. We didn't spin them very much. So if we had spun it 1,000 times, we would see this tally sheet getting closer to 25% each. And if I spun that spinner 1,000,000 times, we would get very, very, very close to the theoretical probability, right? But our experimental probability, we only did it 20 times. So the more we do it, the closer we get to theoretical is what the answer is.